It's not uncommon to struggle with algebra word problems. You could be good at algebra, solving it, the numbers, the problems, the equations, but sometimes just setting up the problem is trouble for people. So in these next few videos, what I'm going to do is show some examples of common word problems. They're all important because after all, most applications in real life are actually using word problems, developing an equation, and then solving it. So let's start with the basics. Here's a few number word problems. We'll start with the first one. It says 3 times a number is 4 less than 40. What is the number? And like most word problems that you're going to get in class, you have the nightmare of a blank sheet of paper and you have to decide, where do I go from here? And what I generally suggest, there's 2 things. First, I suggest reading the problem very carefully and try to pick it apart phrase by phrase. And the other thing I suggest is putting something down on the paper, a variable, a picture, a formula, get something going to get through the problem. Okay, so let's take a look at this problem. Okay, we have 3 times a number. So what I like to do is I like to actually start with a number. And in this case, let's call that number x. Okay, at some point we're going to try to find x. Okay, and we'll even say let the number equal x. And then let's look at the first part of the question. 3 times a number. Well, what does that mean? That's 3 times that number, which in algebra is 3x. Okay? And the next part is 4 less than 40. Is generally means equals. Okay? And then 4 less than 40. Well, we have 40, and let's take 4 less than 40, and here's our equation. And what are we looking for? We're looking for the number, which is x, and it's a straightforward algebra problem. So let's go ahead and solve it. We'll have 3x equals 36. Okay, divide both sides by 3. So you end up with x equals 12. Okay, and the second question we have here is the difference between 2 numbers is 17. If their sum is 189, what is the smaller number? So again, what do we want to do? Well, we want to start writing something down. Let's start writing variables, equations, and eventually we'll solve it and answer our question. So we have the difference between 2 numbers. So why don't we call the 2 numbers x and y? So we have an x and a y. Okay. And the difference means subtraction, right? Sum is adding them, difference is subtracting them. So let's say the difference is x minus y is equal to 17. Okay, again, we'll see where we're going with this. And then their sum is 189. So x plus y equals 189. And we want to find what is the smaller number. And of course, in our case, y must be the smaller number, right? Because x minus y is positive 17. So it's a simple 2 equations, 2 unknowns. So let's we'll use substitution. We'll take this equation and change it to x equals 17 plus y. Okay, we added y to both sides. Okay, and then now we simply take this equation, substitute it into the other equation, and we have 17 plus y equals 189. And then simple algebra, straightforward, 2y, these together, equals, and subtract 17 from both sides, equals 172. Therefore, y is equal to 86. And if y is 86, we go back to our original equation, and that must mean that x equals 103, because the difference is 17. And again, the difference is 17, and the sum is 189. Okay, in our third example, we have 3 actual numbers we're going to be working with. It says 3 consecutive odd integers add up to 237. What is the middle one? So again, let's go back and start writing some variables and equations. So we have 3 consecutive odd integers. So let's call the first one x. Okay. Now, the first one's x. What's the second one going to be? Well, what is a consecutive odd integer? Well, first of all, the integers are all the counting numbers 1, 2, 3, 4, 5, 6, etc., and their opposites, negatives. So if we had an integer of, say, 7, which is an odd integer, the next consecutive odd integer would be 9, and the one after that would be 11, etc., etc. So in this case, we're going to call our first one x, which means our second one has to be x plus 2. This is the first one. This is the second. And the third one would be x plus 3. I'm sorry, it'd be x plus 4, right? So, I mean, you can even think to yourself, this is 7. This would be 7 plus 2, which is 9. 7 plus 4, which is 11. Okay, so these are our three integers. Okay, and these three integers, consecutive odd integers, are going to add up to 237. So our equation is going to be x plus 2 plus x plus 4 equals 237. Okay, so this is our equation. And nice, because we only have one variable we have to work with. So let's add, this becomes x plus x is 3x plus 4 plus 2, 6 equals 237. Okay, and then simple algebra, 3x equals 231. Okay, and 231 divided by 3, both sides by 3, x would equal 77. Okay, now if x is 77, that's the first integer, then the second integer would have to be 77 plus 2, and the third integer would be 77 plus 4. So you have 77, 79, 81. Again, all three of these add up to 237. And we go back to our original question, which was, what is the middle one? Again, we got to remember to always answer the question that we're looking for. And therefore, the middle one is 79. Okay, the last question in this video is the product of two consecutive integers is 132. What are the numbers? So again, we want to write down some variables and formulas and then solve it. Okay, so let's call the first. Let's let n equal the first number, first integer. Okay. Therefore, it's consecutive integers, not even or odd, but just consecutive. So that means the next one in order would be n plus 1 is the second integer. Okay? And then we go back to our question, and again, read the phrases. The product of these two consecutive integers, which means let's multiply them. So n times n plus 1 is equals 132. And we have our equation. We're trying to find the two numbers, which are going to be n and n plus 1. So let's solve this. Again, we'll distribute the n through. We get n squared plus n equals 132. And this is a quadratic. So we'll subtract 132 from both sides. And we get n squared plus n minus 132 equals 0. And if you remember from your algebra, we need to find, we're going to factor this into two binomials. So we need to find two numbers that multiply to negative 132 and add up to 1. And that would be plus 12 and minus 11. If you FOIL this out, you'll find that it equals this. Therefore, n equals 11 and negative 12. Okay? Now, this is very important. Notice how we have n equals two solutions. Okay? If n equals 11, n plus 1 is 12. And if n equals negative 112, then n plus 1 equals negative 11. So we actually have two sets of solutions. So let's go back to our question. The product of two consecutive integers, and again, integers can be odd or even, plus or minus, anything. So let's take 11 and 12 is going to be one of our answers. 11 and 12. And then negative 11 and negative 12 is going to be the other. And we actually have two solutions. These multiplied to 132 and are consecutive integers. These multiply to 132 and are also consecutive integers.